Today I'm going to take a look at idiosyncrasies of tracing network activity with Process Monitor. So here you see we have Process Monitor started. I've set up some filters. I'm just going to filter to look for any operation that begins with the string TCP. I've enabled system process activity so that I can see TCP activity that's actually being executed by the system process. I've excluded svc host and lsas.exe. I've excluded svc host because periodically things kick in and cause network traffic, and I've excluded lsas because that's the authentication traffic going to the domain controller, and I'm not so interested in that just for this particular exercise. So those are the filters. All importantly, I've also set drop filtered events, which means that it's like a capture filter in Wireshark. I'm only going to capture the events that obey the filter. So let's start that running, and let's go over here and just refresh this browser showing Google. Now I'm going to stop this one. A couple of things to notice. The process ID is the process ID for Internet Explorer, but if you notice the thread ID is set to 0, which is a bit of a surprise because perhaps you might think that the calls to the WinSock interface are being made by a thread within the process, and so why aren't we seeing the thread ID? Well, if we take a look at the stack, what we find is, if we go right down here, what we're seeing here is we're seeing an interrupt being dispatched by the kernel or by code within the kernel, and we're processing the result of an interrupt on our network interface. This is the name of the NDIS driver for my network interface, and that drives up through the TCP/IP stack. Now the reason that we're seeing this is because actually Process Monitor registers the completion of the event. So it doesn't register or record a log entry when we actually make the WinSock call and do the send. What we see is the completion, and the completion, believe it or not, is when we see the acknowledgement for the packet that has been sent. So that's quite important because the timings we see on the send packets are actually, so that's the actual time, which I'll just expand out over here. This is telling me that actually this send for 198 bytes over here, that's the TCP length, 198 bytes. This send completed at 130810.847. And completed means that's when I got the ACK for the send. Similarly with receives, it's probably quite what you'd expect, that we see the receive complete when we receive the packet. And again, that will be driven by an interrupt, and so we can see. The thing to notice here is we don't see any activity in user mode. It's all in kernel mode, this K that we see down here. And I think that explains why we don't see the thread ID. Okay, so that's Internet Explorer. Let's try something slightly different. I'm going to clear the trace, start it again. This time I'm going to double click on a document here. Just to explain, I just double clicked on a text file that's located on a remote computer, which is actually mapped to my Z drive. So let's go to Process Monitor. We'll stop the trace again. Now here's something slightly different. The file opened in Notepad, but if you notice there's no mention of Notepad anywhere in this trace. And the reason for that is because Notepad simply performs file operations, and the kernel converts those into remote file calls that get mapped onto TCP connections. And so In fact, the remote access is all done by the kernel. So there's this disconnect between Notepad performing an operation and us actually seeing trace entries in the process monitor trace. This can be quite confusing because some people try and filter on a process name of Notepad and they don't see any activity, which leads them to believe that they didn't actually capture it. So again, if we just have a quick look in here, we see the same thing. Everything is in kernel mode, there's no user mode activity, and if you start down here you can see that we start off by dispatching an interrupt, and then we move up through the NDIS code into the TCP IP code. This is the TCP IP software driver that resides in kernel mode, all the way up to the top. So I hope you find that useful. I'll speak to you soon.